So as I proposed the red line of the panel, which is now we have data, or we want to have data and even more, and what about moving those data within the grid and the cybersecurity? Romain, the floor is yours.
Thank you very much. Yes, we need data from the grid, and we need power from the grid also in order to make our smart cities, EV, mobile, all what we have heard the last days. All this system needs to have power and reliable power. So my name is Romain DOUIB. I'm from France, but living in Sweden. So I'm a Swedish company. And we are specialists within 61850, which is the protocol with the communication protocol into the power grid and the substations. We do product and services, and we are expert associated coming from different companies, everything from power companies to telecom companies and software companies. Yes, what is the grid? The power grid. Yes, it was analog in the past, and it's still in many places. And it was very simple. It was very hierarchical, from the generation all the way down to the consumption and the distribution. Nowadays, it's more interconnected and distributed, digital, smart. And all this, in order to work, needs to communicate. And the communication is called 61850 under the standard from IEC. IEC standards came from the UCA group originally from the US and evolved into the IEC 61850 standard. This standard is one of the standards that is worldwide applied. All countries in the world are using 61850 when they develop the new digital substations. So, which is a chance for us to leverage that globality. But 61850 needs a new tool. We cannot use our multimeter, voltmeter, the standard tool that our power engineer use today. Different mindset also. We have an IT world entering in our substation, which is another platform for our engineers. So 61850 is all about the line that interconnect within the stations and outside the station to the control center, as this slides show. So what I would like to highlight today is the protocols, how they're built, and how they are secured from the beginning. When they were defined, there is some settings that make that they are secure in themselves, or there's certain watchdog that allow some security. Then there is also comparison mechanism inside that allow to verify the integrity of the network, which is also a security at the end. And then what tool do we need, and what tool do we have today? So I'm coming back to that. We are setting up a new station, digital station. So we commission a station. It's all about to make this station working. When we do maintenance, we are still doing that, but we are verifying the system is still working. And this is slightly different, but this is very, very much the same. We are always verifying, and we need to verify when we set up any type of system, we need to verify that it does what it's meant to be done. Now, just a very short picture showing the topology of schematic of a substation and the two protocols that are inside the station. There is a well-known SCADA communication, which is mainly used from the station outside to the other stations or to the control center. There is also SCADA that command the so-called HMI, all the visualization. But when it comes to the process inside, we have the protocol called Goose that interconnect digitally the different elements in the station. And we are more and more finding what we call the sampled values. So the VTs, voltage transformer, and the CTs as we know them today, analog, they become digital. And if they are not digital, we use so-called merging unit in order to fill the gap. But I can say today, the new station in place are integrated digital voltage and current center. So it's digital from the beginning all the way to the control center. So the analog part is removed. So just a mechanism explaining, looking at the protocol itself for goose or for sample value. There is a mechanism that we call the data string, and the data string contains the information. But for each information that is broadcast, there is a quality string. There is a string that follow each message, and this string is very smart. It has a lot of functions, and that failures functions or information that inform of the status of the data that is sent. The data can be old. If it's old data, this is resend, for example, the flag will be set to true. If it's the source is failed or the receptor is failing, we will also get that information. If there is a communication loss, then we will see that also in that. So by monitoring the data and the string, then we are sure that we get the data that is fully integrated, the integrity of the data is fully proven. So just simple, and graphically it can be shown that way. You can see a frequency that is broadcast, and when the frequency gets crazy on the zero, kind of failure, then the quality, the color of the quality string on the bottom from black go to different color type, representing the failure. So you can only trust on the data that is undersigned with a black straight. There is another mechanism in the protocol that is repeatability. So when you get a trip for a command to trip a breaker, this trip is sent by the relay. The relay takes the order and send a trip. But it's not sending one trip, it's sending one trip at different time and irregularly. So there is if we are not reaching the first information, then we have a chance to reach the second information. So there is a mechanism here that allows to be sure and safe on when we trip a breaker that this is really meant to be trimmed and nothing else. We can also looking at communication loss. There is something called ghost goose. So a goose that a message that appear and that disappear a while and reappear again. So it's seen as a ghost. So he was there and disappeared and reappeared. So this information is also available from the protocol itself. Now, all the new station, digital station, 6180 station, are based on documentation. This documentation is not anymore a binder or a schematic. This is a file, XML file. We call it the SCD file. And this SCD file contains all the settings, all the elements in the station and their own settings. This is commissioned at the day one, and this should be kept in the integrity over time. If there is a change in the station or update of the station, this file will be updated. So by a tool comparing this file and the actual sniffing or the actual capturing of the information, and if there is full matching of the information, you can be sure that you are no intruder, that you have a full, stable communication network. You can compare also over time two different scanning 1 year ago and this year, and you can see that there is also the integrity is kept over time. Another aspect that is more close to the reality also in terms of threat. Today and in the past, we have been using laptop and software in order to set up our relays and station, and we can still do that today. But when the day you commission the station, you put the station live, then the PC become a threat. The PC you don't have control about your Microsoft or iOS operating system. You don't have control of the Ethernet port. So the problem is do you dare take a PC and connect to a switch in the station, as I saw in this picture here? I will not dare to do that, and I will not do that. My customer asked me since 2 years ago, are you safe to connect to my station? And I say, yes, I can, because it's not a PC. So our tool needs to be not a PC. It needs to be dedicated. They need to be safe in a term of we are sure that we are not publishing information, because if we publish something we are not declared in the SAL file, that means that the other equipment in the station will not recognize us, and that will create a disturbance, and we don't want those disturbances. And the last thing also I missed to mention is that everything in the station is time synchronized. And in our days, when you use sampled values, we are time synchronized in a microseconds level. So we cannot afford to delay, and the PC is not able to synchronize itself at microsecond level. So the tools need to be different in order to be sure to connect safely your connection. So using SafeE or software, think cybersecurity before. And I say that because I know that today PCs are still in use in live station, but it's at your own risk. You may shut down your city close to the station. So use dedicated and secure tool. That's the key message and takeaway for today. Use the quality mechanism, the quality string and the repetition and the mechanisms that are in the protocol. They are there to be used and to be monitored. And use comparison in order to make to be sure that your network is integer itself. And also another part that's more IT-wise is that the switches that you have in the station can be programmed in a way that you are not disturbing. That's another possibility to solve that problem. Thank you.